What is the limit of 6x over x squared plus 3 as x approaches infinity? The technique applies to both positive or negative infinity. So what do? We say we divide by what? X to the highest power. So that would be 6x over what? X squared divided by x squared over x squared plus 3 over x squared. And you end up with limit 6 over x divided by what? 1 plus 3 over x squared. We covered that topic in chapter 2, didn't we? Yep. And we said anything that has x or x squared in the bottom of it will go where? To 0. So these two will go to 0. Your answer will be what? 0 over 1 plus 0, which is 0. If the function is bottom heavy, what do I mean by that? Yep. The exponent in the bottom are larger than the top. The result is always going to be what? Always going to equal to 0. Always. That's the shortcut I use. Bottom heavy, the result is 0. What about this problem? The limit as x approaches infinity, 5x squared plus 3 over 2x squared minus x. Again, we're going to divide everything by what? X to the highest power, in this case, will be what? X squared. If you divide by x squared, what is 5x squared divided by x squared? 5 plus, this will be what? 3 over x squared. This will be 2 minus, what's x over x squared? 1 over x. So anything that has x in the bottom will go to 0. So the answer is going to be what? 5 plus 0 over 2 minus 0, and the result is 5 over 2. You notice anything? If the exponents, the highest exponent is the same on the top and the bottom, you divide what? The coefficient. That's the shortcut. If the highest exponent is the same for the top and the bottom, take the number here, divide it by that number. So shortcut from now on, if you see a problem like this, again, doesn't matter if it's plus or minus infinity. I don't care how big that number. Are the highest exponents the same? So what's the answer? 7 over 9.
Why does number divided by x go to 0?
Because x approaches infinity. So for example, take that number. I made that intentionally big. 100,000. divided by a number 10 times the size of that, it becomes 0.00000000000001. So that's a 0. I was just peeking to see if our book does slant asymptotes. I don't see him, but if we encounter, wait, I might see him. Oh yeah, they do talk about slant asymptotes. I just saw an example there. What about if the exponents on the top is larger than the bottom? And our book is only doing 1 degree higher. So what's the limit? Well, if you use the rule, you divide by x to the highest power, right? Which is x squared. So you end up with what? You end up with the limit, which is a problem. The limit of 2 minus 4 over x, because I'm dividing everything by x squared. By x squared, this is 1 over x plus 1 over x squared. Anything that has x in the bottom of it or squared will go to 0. So we'll have what? 2 over 0, which we know we got a problem. So what does that mean? What I need to do to fix that problem is do long division. Divide this by this. And where we're going to have something called slant asymptote. Let's see, how do we divide them? So when you have a problem like this, where the bottom is 0, or top heavy, if it's top heavy, you'll have a slant asymptote. So we're going to divide them. Long division. And the first thing we do to divide them is we look at 2x squared and we go, what is 2x squared divided by x? 2x. What's 2x times x? 2x squared. What's 2x times 1? Plus 2x. Now we need to subtract them, just like if you were dividing numbers. What is 2x squared minus 2x squared? Gone. What's negative 4x minus 2x? Negative 6x. Now let's take the negative 6x and divide it by x. What are you going to have? Negative 6. Negative 6 times x. Negative 6x. What's negative 6 times a 1? Negative 6. And let's subtract them again. Gone. Nothing minus negative 6. That's a plus 6. So you can write that as 2x minus 6 plus 6 over x plus 1. This is the part I'm interested in. This is the equation for my slant asymptote. Let's see how that's going to help me for this problem. I'm doing this problem. I'm going to graph this one. I'm going to go through the entire process there. So here's the problem. F of x equals 2x squared minus 4x over x plus 1. This section, each problem is actually, that's the lengthiest type of problems you'll see. You can see half an hour to a problem sometimes. First thing first, I have a vertical asymptote. Where is it? At x equals what? -1. That's when the function is undefined. Can't divide by 0. Everyone see that? So quickly, let me go to my table. This is for the second derivative. This is for the first derivative. We said x cannot be -1. So I'm going to draw a thick line at -1. -1 and undefined. Going through the first derivative and the second derivative. I know it's going to be there. If I go to graph that, this is the -1 right there, the vertical asymptote. So as I approach this line, I'm going to go to plus infinity or to negative infinity. That's why I draw arrows, by the way. I draw an arrow up or down. I'm saying as I approach that one, I'm either going to go to plus infinity or to negative infinity. So if my function is decreasing, it's going toward negative infinity. If it's increasing, it's going toward plus infinity. I also did this problem for the horizontal asymptote. I said, well, let's find out the horizontal asymptote. I divided that problem. That's how I started the problem with. I came up with the slant asymptote of 2x minus 6. So what does that mean, 2x minus 6? So I have a slant asymptote. We just did that. At 2x minus 6. Or slant asymptote, not at. Well, y equals 2x minus 6. You can, I don't like the word at. But that's the line, that's my slant asymptote. Y equals 2x minus 6. So when I graph that line, 2x minus 6 has a y-intercept of -6. Has a slope of 2. So this is my slant asymptote. Looks something like this. Let me extend this line. I really have no idea what the graph looks like. So in case you think I know the answer, no. But we'll find out what that answer is. If you extend that line all the way, I wish I had more space there. I can make my slope a little bit like flatter. You know what? I'm going down here. Let me make my slope a little bit less sharp. I know it's -6. I'll fudge it a little bit there, because otherwise I'm going to be crossing. Let's make it like this. Let's see if that helps me. Okay. Try to give myself some room, some space there instead of down here. I didn't do anything yet. I just said I have a slant asymptote. It looks like this. I have a vertical asymptote. That's this line. That's all I know so far. I need the first derivative. Do I have the first derivative? I don't have it. So here's the good news. It's my TI-89 here. TI-86. TI-89, my friend. The battery is dead. So right, I'll take the battery from, huh? No, I got another calculator here. I'll just take the batteries from the other one. I don't have any fingernails. It's great. Now we've shown everyone how to replace the battery on your calculator. Part of the lecture now.
Is that going to be on the test?
Yes. It's actually fun when you're recording and they'll tell you, never make sure, you just get to the point, just do the stuff and get out. Well, it doesn't work that way. Uh-oh. Ooh. Look at all the acid from this battery. I don't have any fingernails. But here's the good news. I have one more battery, so I'm not using this one. I'm not really environmental friendly here, so. I have an extra battery sitting here. Plug it in. Let's see if that will do it. Come on, work please. Here we go. The derivative of that. I'm going to take the derivative. What was the function? Right here. So the derivative of this, I don't write it yet. 2x, where's x? 2x squared minus 4x divided by x plus 1 according to my calculator here. The answer is 2 times x squared plus 2x minus 2, all of that divided by what? X plus 1 squared, if you simplify it. Again, the quotient rule will be the way to do it. You get a fraction. Quotient rule will be perfect. Where is the derivative and define? And define when what? When x equals -1. No surprise, I know that. I already put it in. Where is the derivative equal to 0? Oh no. That's when the top is 0. I just made a problem, so I didn't think about it. And that's not going to be nice, because I can't factor it. I got to use the quadratic formula to solve it. -2 plus or minus the square root of what? 4 minus. Oh, perfect. Oh no. 4 times a times c, which is -2. Too bad. I was hoping for a negative value. Negative 2 plus or minus, that's the square root of what? 12? Hmm. 4 times 2 is 8. That'll be a plus 8, plus the 4, that's a 12. Ugly. Ugly, ugly, ugly. We get decimal values for that. What is the square root 12? I got a syntax error. Square root 12. 3 point, well, I'm just going to get decimal value. 3.5 roughly. So I'm going to have two values. One of them, negative 2 minus 3.5. Divided by 2, negative 2.75. And the other one's going to be what? Negative 2 plus 3.5 divided by 2 is 0.75. So where's the 0.75? Somewhere here. Too many things all over here. It's late and I'm starting to get like, nah, should have thought about this. 0.75, and I got to find the y value. And the other one somewhere here, negative 2.75. And I need to find the y value. I'm worried about the second derivative. Could be ugly. So when it's negative, let's see what that number is. Where'd you go? Two x squared minus 4x divided by, well, what is x plus 1? My calculator, this one's like dying on me. Everything is missing in the bottom. I can't even read anything on it. I gotta do them by hand, one by one. Okay, 2 times 2.75 minus 4 times negative 2.75. The other one's 2.75 squared here. Minus 4 times negative 2.75. Take that answer, divided by negative 2.75 plus 1. Roughly negative 15. When it's 0.75, 2 times 0.75 squared minus 4 times 0.75 divided by 1.75. Roughly negative 2. Ugly numbers, but I can live with them. Let's take a value less than negative 2.75. How about a negative 3? How about a negative 2? How about a 0.5? How about a 0? 0 is even better, right? Why kill myself? And how about a 1? What is it?
5, 7, 1.
Yep. So I'm going to take a test point for each one of these and plug into the derivative in the bottom. Here's the good news about the derivative. Notice the bottom here is what? Positive, because you square it. So I don't have to waste my time on that one. The 2 is positive. I don't have to worry about that one. So what's f prime of negative 3? I know the bottom is positive. What about the top? That would be a 9 minus 6 minus 2. Positive or negative? It's positive, right? So it's increasing. I don't care about the 2 in the front. It's a positive number. Let me try the negative 2. That's a 4 minus 2. That's a negative. That's decreasing. Notice increasing, decreasing, that's what? A max point. Now let's try the 0. What's f prime at 0? At 0, the bottom is positive. The top, 0 squared is 0 plus 0 minus, that's a negative 2 times 2. That's a negative. Decreasing. And let's try the 1. One plus 2 minus 2, how about a 1? Positive over positive, and that's a positive. So the first derivative test is done. I know the min, I know the max, I know where it's increasing, I know where it's decreasing. Nothing else. Finish the first derivative. Now I got to take the derivative of the derivative to get the second derivative. And the good news is I plugged onto my calculator here, and my calculator just told me the second derivative, you're going to like the answer. After you take the derivative of this using the quotient rule and simplify your answer, magically it becomes 12 over x plus 1 cubed. Beautiful. That's my second derivative. Where's the second derivative equal to 0? That's when 12 equals to 0. That's never. Where's the second derivative going to be undefined? That's when x equals negative 1. I knew that. I already have the line going through it. So I only have to use one test point to the left, one test point on the right, then I can start graphing. Less than negative 1, I'll use a negative 2. More than negative 1, I'll use a 0. What is the second derivative? The value of the second derivative at negative 2. I know the top is 12. That's positive. This will be a negative 2 plus 1, which is negative 1 cubed. That's a minus 1. That's a negative. Negative, it means what? Concave downward. And let's try the 0. (12 over 1), which is positive, and that's concave up. Now we're going to see how these vertical asymptotes going to work. Negative 2.7 minus 15 is down here, somewhere here. Notice this is an asymptote. It says up to this line, up to that point, your function is increasing, it's concave down. Well, if it's increasing, it's coming from this area. Asymptote to that line. Then what happens when it hits that point to the red line? It's going to decrease concave which way? Downward. It's going to look like this. The next value is right here. From the red line to the blue line, that's from the red line to this point. The red line to this point. My function is decreasing concave upward. And what happens when you hit that point? Increase in concave which way? Upward. Notice how it approaches that line. It will never go away from that line. You can't cross it. So the vertical asymptotes, they let you know how tight that graph is. Because if I said increasing, some of you might think it's like this or wider. This one tells you how tight is going to be the graph right there. Like if I can stretch this, you'll see that too. So that's the significance of the the slant asymptote. That's the slant asymptote right there. I'll stop here. Everyone looks